everyone, myself Anasha. So today we are going to discuss the topic of complex numbers. The definition of complex number. So complex number Z is an ordered pair x comma y of real numbers x and y. So this x comma y belongs to R, right? That is Z is equals to x comma y can be written as x plus iy, where our x and y belongs to R, and we know that I is equals to what? Square root minus 1. Okay, so here this x is called the real part of z and it is denoted by Re of z. So x is equals to real part of z, that is equals to Re of z. So this is the notation of real part of z. And y is called the imaginary part of z and it is denoted by Im of z. So this y is called the imaginary part and it is denoted by Im of z. Okay. Now if x is equals to 0 and y not equals to 0. So in this I put x is equals to 0. So z will be equals to 0 plus iy. So z will be finally equals to what? Iy. And this kind of complex number is known as purely imaginary. Okay. Now the next criteria, if x is not equal to 0 and y is equals to 0. So in this put y is equals to 0. So only x will remain, right? So this is called a real number. Okay. So now let us move on to some notes of or remarks of I. So we know that I is equals to square root minus 1. So we can write this as I square is equals to minus 1. So I cube will be what? I square into I. But we know the value of I square, that is minus 1. So I cube is equals to minus I raised to 4 means I square into I square. So minus 1 into minus 1. So answer is 1 and so on. So what we can conclude from this, that whenever we have even power of I, that is if we have I raised to 2k, answer can be 1 or minus 1. And if I have odd power of I, that is I raised to 2k plus or minus 1, right, then the answer will be what? Plus or minus I, right? So this we can conclude. So now next, the complex number z is equals to x plus iy is said to be a zero complex number if x is equals to 0 and y is equal to 0. So 0 complex number can be written as 0 plus I times 0. So such numbers are known as zero complex number. Now two complex numbers z1 is equals to x1 plus I by 1 and z2 is equals to x2 plus I by 2 are equal if x1 is equals to x2 and y1 is equals to y2. Then these complex numbers are equal. The next condition, two complex numbers z1 is equals to x1 plus I by 1 and z2 is equals to x2 plus I by 2 cannot be compared. That is, we cannot compare two complex number in sense of z1 less than z2 or z2 less than z1. This is not possible. That is, we cannot compare the two complex numbers, right? Next, let us study the geometrical representation of complex numbers. So how can we represent the complex number in the xy plane? So let us study that. So complex number z is equals to x plus iy can be represented as a point P of x comma y. We know that complex numbers x plus iy is an ordered pair x comma y. So we will represent the complex number as P of x comma y in the xy plane. So such type of diagram is known as Argand's diagram, right? This name is given on the name of Robert Argand, who is a French mathematician, right? So based on his name, we are giving the name as Argand's diagram. So the x-axis is called the real axis, you can see over here, and y-axis is called the imaginary axis in the xy plane, right? And this name is known as complex plane, right? This plane whole is known as a complex plane where we are denoting our complex number as P of x comma y. So this you have to remember, right? This can be asked as an example. So now let us study algebra of complex numbers. So if z1 is equals to x1 plus I by 1 is one complex number and z2 is equals to x2 plus I by 2 is the second complex number, then how can we add these two complex numbers? Simply write z1 plus z2 is equals to x1 plus I by 1 plus x2 plus I by 2. Now what we will do, we will separate the real and imaginary part. So here you can see the real numbers are x1 and x2. So what we can write it as x1 plus x2 plus, take out I common, so I times y1 plus y2. So for addition of two complex number, we have to add the real term separately and imaginary term separately. For example, let us take two complex numbers z1 as 1 plus I and z2 as 3 plus 2y. So if I want to add this z1 plus z2, just add firstly the real part, that is this. So 1 plus 3, it will be 4 plus. Now add the imaginary part, so it will be I plus 2i, so it will be 3i. So this is addition of two complex numbers. Now subtraction. So again you have to subtract the real part and imaginary part separately. So z1 minus z2 will be x1 minus x2 plus I times y1 minus y2. So using this example, let us similarly find z1 minus z2. So first what you will subtract the real part. So 1 minus 3. So answer will be minus 2. And next, I minus 2i. So answer will be minus I. Right? So this is the subtraction of two complex numbers. Now next, let us study multiplication of two complex numbers. So z1 into z2 will be what? x1 plus I by 1 into x2 plus I by 2. Open the bracket, so it will be x1 x2 plus I x1 y2 plus I y1 x2 plus, if I multiply this, it will be I square times y1 y2. But we know that I square is equals to minus 1. So here this will become minus y1 y2. Now again separate the real and imaginary parts. So your answer will be x1 x2 minus y1 y2. From these two, take out I common. So in bracket what will come? x1 y2 plus y1 x2. So now let us multiply two complex numbers. So again let us take our z1 as 1 minus I and z2 as just I. Right? Let us multiply these two, z1 into z2. So just we have to multiply 1 minus I into I. So start your multiplication. So it will be I minus I square. But we know that the value of I square is what? Minus 1. So answer will be minus minus 1 plus I. So final answer will be 1 plus I. Okay. Next, division of complex numbers. So z1 upon z2. So x1 plus I by 1 upon x2 plus I by 2. So in this, whenever something comes in the denominator as a complex number, we have to take conjugate. So conjugate of this will be what? x2 minus I by 2. So multiply and divide by that. Now just here you can see the formula we can apply is of a square minus b square, that is what? A minus b, a plus b, right? So in the denominator what will become? x2 square minus I square y2 square. Now we know that the value of I square is what? Minus 1. So here in the denominator what will become? x2 square plus y2 square. Now you can open this bracket, so bracket in the numerator will become x1 x2 minus I times x1 y2 plus I times y1 x2 minus I square times y1 y2. Again keep I square as minus 1, so this will become plus y1 y2. Separate the real and imaginary parts. So the real terms will contain x1 x2 plus y1 y2 plus I times the remaining things y1 x2 minus x1 y2. You can separate these two and write in this manner. So let us find the division of complex numbers, that is z1 we can take as 1 plus I, z2 as what? 2 minus I. Fine. So now let us find Z1 upon Z2. So 1 plus I upon 2 minus I. Let us multiply by its conjugate. So 2 plus I upon 2 plus I. Now just in the denominator we have to apply the formula of A minus B, A plus B. It will be A square minus B square. So 2 square minus I square. And in the numerator we just have to open these brackets. So 2 plus I plus 2I plus I square, right? Just you have to open the brackets. Now simplify this. So I square will be what? Minus 1. So 2 minus 1. 1 plus 3I upon 4 square minus 1. So total what will remain? 5. Now just separate and write it out. So 1 upon 5 plus I times 3 by 5 is the answer. Okay. So now, what is the conjugate of a complex number? Just we have studied the conjugate of a complex number z is equals to x plus iy is denoted by z bar and is defined by z bar is equals to x minus iy. Okay, so this is known as the conjugate of a complex number and this is its notation. Now the two complex number x plus iy and x minus iy are said to be complex conjugate of each other. Fine. Now let us study few properties of this. So if z is equals to x plus iy and z bar is equals to x minus iy, then we can prove this, right? That is real part of z means x is equals to z plus z bar upon 2. So this is one kind of example also. So firstly we will find z plus z bar. Now your z is x plus iy plus your z bar is x minus iy. Add this, so this will get cancelled out. So only 2x is remaining. So from this we have obtained that real part of z or x is equals to what? Z plus z bar upon 2. So this we can remember also that x is equals to z plus z bar upon 2 and it is also known as real part of z. Next, if I subtract these two, so z minus z bar is equals to x plus iy minus x minus iy. Now if you open the brackets, this x will get cancelled out. What will remain? 2i. So now make y as a subject. So y is equals to z minus z bar upon 2i. Okay, which is our imaginary part of z. So finally what we have derived, that imaginary part of z is equals to y is equals to z minus z bar upon 2i. So this can be asked as examples also. Okay, so now let us study few more properties. Now if we have two complex numbers z1 and z2, then what we have the first property as conjugate of z1 plus or minus z2, right, is equals to conjugate of z1 plus or minus conjugate of z2, right? So let me explain this property. So if z1 is x1 plus iy1, right, and z2 is x2 plus iy1. So its conjugate will be x1 minus iy1 and z2 bar will be x2 minus iy2. First, let us begin with the LHS. I will only find first Z1 plus Z2. You can similarly find conjugate of Z1 minus Z2. Right? That is, you can write yourself. So, we will write it as x1 plus iy1 plus x2 plus iy2. Right? Now, just separate the real and imaginary parts. So it will be x1 plus x2 plus I times y1 plus y2. Now the conjugate of this will be what? x1 plus x2, just you have to put minus in between, minus I times y1 plus y2. So this is your LHS part. Now RHS, that is what? Z1 bar plus Z2 bar. So now if I put the values of Z1 bar, it is x1 minus iy1 plus x2 minus iy2. Fine. Now we have to just separate the real and imaginary parts of this. So it will be x1 plus x2, take out minus I common, y1 plus y2. So you can see that LHS is equals to RHS. Similarly, you can find that conjugate of z1 minus z2 is equals to z1 bar minus z2 bar. And you can also prove these properties, that is conjugate of z1 z2 is equals to conjugate of z1 into conjugate of z2. Just find the LHS and RHS and obtain the results. Similarly, it is applicable for division also. That is conjugate of z1 upon z2 is equals to conjugate of z1 upon conjugate of z2. Now the next property, conjugate of z1 will be equals to z1. Let us find that. We know z1 is this, its conjugate is this. Let us find one more time conjugate. So again conjugate of z1 will be what? x1 plus I y1, right? From this you can see conjugate of z1. Conjugate of z1 is, again you can see it is z1. So we have proved this also. And last, z1 into z1 bar, that is a complex number and its conjugate. If we multiply these two, answer will be x1 square plus y1 square. You can see from here, if I multiply these two, that is z1 and z1 bar, apply the formula of a plus b and a minus b, it will be x1 square minus I square y1 square. But our I square is what? Minus 1. So you can see it will be what? x1 square plus y1 square. Okay. So I hope you have understood throughout the session. Thank you for watching.